Hello students, let us discuss preparation of alcohols in this video. We need to discuss preparation of alcohols from haloalkanes, reduction of carbonyl compounds, Grignard reagent, acidic hydration of alkene, and from hydroboration oxidation reaction. So we need to discuss this separately one by one. So let us discuss first preparation of alcohol from haloalkanes. As we have discussed in the previous video, in the previous chapter, haloalkanes, that is the one of the property of haloalkane, that is in the nucleophilic substitution reaction, we can say that when it is treated, haloalkane is treated with aqueous NaOH or aqueous KOH or AgOH or H2O. From any of these, we can say that we are getting alcohol as a product. So that is a substitution reaction in which X is replaced by the nucleophile OH. That is a nucleophilic substitution reaction. So from this method, that is one of the property of haloalkane, we can prepare alcohol. So this is one of the method of preparing alcohols. Next, from reduction of carbonyl compounds, we can prepare alcohol from reduction of carbonyl compounds. So before discussing about this reaction, let us discuss what is carbonyl compounds. Compound consists of C double bond O group is called as carbonyl compound. That means the group that is C double bond O is called as a carbonyl group, and the compound containing this group is called as carbonyl compound. Let's take the examples. If there is one R dash and H here, so you can see the carbon have 4 valency. From the 4 valency, one is satisfied by the alkyl group, the other is satisfied by hydrogen, and here there is one double bonded O. So in that case, that compound having a group that is, we can say, now it have a functional group that is C double bond O group, that is CHO group. That group is called as aldehyde group. So such type of compounds are called as aldehydes. So aldehydes are the carbonyl compounds. If from the 4 valency, if the 2 valencies are satisfied by the 2 alkyl groups, as you can see here, and there is a carbonyl group here, so such type of carbonyl compounds are called as ketones. Ketone have functional group, that is a functional group C double bond O is the functional group which is present in ketones. So that is a carbonyl compound ketones. If there is OH group, that means one of the valency of carbon is satisfied by OH group, which you can see here, that time the compound having a functional group, that is COOH. We can see the functional group COOH. So such type of compounds are called as acid, that is carboxylic acid. So the carboxylic acid having a functional group, that is, the functional group is called as COOH functional group. That means acidic group COOH. COOH means C double bond OOH. That is the acidic group, and it is a carboxylic acidic group, and such type of compounds are called as carboxylic acid. If it is one of the carbon is having alkoxy group, that means if this group is present and one R group, that means alkyl group, this group is called as alkyl and this group is called as alkoxy group. So in such case, and there is one of the carbonyl group is also present, in such a case we can call this type of compounds as esters. So ester, in short, how we write ester? That is RCOOR. So we'll write ester in this way. What the dash means? Dash here R dash. What means that it is not necessary that both the alkyl groups can be same. It can be different also. Like if I'm writing R, what it shows that both the R, that is both the alkyl group are same. But if I write RCOOR dash, what it means here the two alkyl groups are different. So it is not necessary that always the two alkyl group should be the same. It can be different also. So such type of compounds are called as esters. So we have gone into the examples of carbonyl compounds, that is formaldehyde. When it is called as formaldehyde, when the two carbon having two hydrogen and with the carbonyl group, then it is called as formaldehyde. The next one is that is aldehyde. Aldehyde having one R and one H. When two R's are there, then it is called as ketone, and one R and one OH is there, then it is called as acid, and when one R and one OR is there, then it is called as esters. So these are the carbonyl compounds. So we have written the general structures for these. Now let us discuss how we can prepare alcohol from these. That is reduction of aldehyde and ketones. Aldehyde and ketones are reduced to the corresponding alcohol either by the addition of hydrogen in the presence of a catalyst like platinum, palladium. Such reaction is called as catalytic hydrogenation. Hydrogenation means addition of hydrogen in the presence of catalyst. That process is called as catalytic hydrogenation. That means addition of hydrogen in the presence of catalyst. Usually, the catalysts are taken as finely divided metals such as platinum or palladium or nickel. It can also be prepared, that is, alcohol can also be prepared by treating the aldehyde and ketones with reducing agents like lithium aluminium hydride or sodium borohydride. So these two are actually a very good reducing agent. Which two? These two, lithium aluminium hydride or sodium borohydride, that is NaBH4, are the very good reducing agent. So it will help in the reduction process. So as we have discussed previous year, reduction means addition of hydrogen and removal of oxygen. So the reduction takes place with the help of reducing agent. So here lithium aluminium hydride or sodium borohydride are act as reducing agent. So let us discuss the reaction. In this reaction, that is a reduction of aldehyde and ketone. First, let us take the case of formaldehyde. Formaldehyde, which one is the formaldehyde? This structure is called as formaldehyde. So in this you can find out with the carbonyl group, we can say that there are 2 hydrogen. You can see there are already 2 hydrogen. Now during the reduction, what happened? This double bond break. And one H you need to add on this side. One H you need to add on this side. So you can easily frame the product. Now look at the product side. In the product side, you can find out there is an alcohol. So how this alcohol is formed? Previously there was 2 hydrogen here. Now you can find out 3 hydrogen here. So that is 1 hydrogen is added there. Hydrogenation, addition of hydrogen. So 1 hydrogen is added here and 1 hydrogen is added to the oxygen. So we got this product, that is alcohol. So what you need to do here, you have to break this bond and 1 H you need to add with oxygen and 1 H is to be added on this carbon atom. So you got this product. Similarly, when we do for this case, second case, break the bond, double bond, 1 H with the oxygen add and 1 H you have to add with the carbon. So you will be getting this product. And similarly here also 1 H you need to add here, 1 H you need to add here. So we get this product. So this is the method. Actually the hydrogenation takes place, the addition of hydrogen takes place. There is a breakage of double bond and addition of hydrogen with 1 oxygen and with the carbon of the carbonyl group. So when you look at the reaction carefully here, in this you can find out the aldehydes, the first 2 are aldehyde and it giving rise to a product that is a primary alcohol. When you find it out, these 2 are the primary alcohols. That means the reduction of aldehyde give rise to primary alcohols. But the third example, that is actually a ketone and it give rise to a product that is secondary alcohol. So from this what it is clear that reduction of aldehyde give rise to primary alcohol as a product and the reduction of ketone give rise to secondary alcohol as a product. So that you need to remember these 2 cases here. Now how we can make easily the product, what you need to remember here. So let us take one by one the reaction with the example. First, reduction of aldehyde. You know that aldehyde group, that is CHO group is called as aldehyde. So with the addition of hydrogen in the presence of a catalyst, we get a alcohol as a product. Now when you look at this equation carefully, here the group that is CHO is marked with red color and here the product which is formed alcohol in which the red color marked is CH2OH. So that means you need to do the changes only here. That is, change the CHO group with CH2OH. So how easily you can make the product? Remove CHO from the aldehyde and keep CH2OH in the place of CHO. So that will be easily gives the product. R not matters. Whatever the R is there, it not matters. So whatever R is there, keep the R as it is, the alkyl group as it is. You need to make only changes in the functional group, that is change the aldehyde group and keep CH2OH. Let us take one example. If X here, if R is a methyl group, then we have the formula CH3CHO plus hydrogen in the presence of palladium. So what we get the product, we get a alcohol. So what you need to do here, CHO, change CHO with the CH2OH. So that is an easy method. A hint that I can tell you here, that is remove the CH, remove the CHO and add CH2OH in the place of CHO. So that is a very good hint which I can give here in order to make this reaction very easily. So in this case, you can find it out that the carbon number remains same. How many number of carbon is taken in the reactant? Here 2 carbons are there, 2 carbon aldehyde, and give rise to 2 carbon alcohol. That means carbon number is not changing in this reaction. When we talk about ketones, in the place of ketone, this is all the reaction which is given in the textbook. So what you have to do here, how you can make the product easily? Remove C double bond O, that is CO group, and in the place of that you add CHOH in the place of CO. That give rise to the product very easily. So how you do this reaction for ketones? Remove the CO from the ketone and in the place of ketonic group, that is CO, keep CHOH. So that will give rise to the product very easily. So this is the hint which I want to tell here to make the product very easily. Let us take one example. That is this example. It is a ketone where 2 R's are the CH3 group, CH3CO, CH3. So when we do the reduction in the presence of reducing agent, that is NaBH4. So what we get? The product, that is alcohol. So how you are making the product very easily? That is, remove the CO group and you need to add CHOH. So that gives rise to the product very easily. So when you compare this one, it is a secondary alcohol. That means the reduction of ketones give rise to secondary alcohol. Similarly, when we do the reduction of carboxylic acid, that is having a functional group, that is COOH. COOH is the functional group present in carboxylic acid. So when we do the reduction of this one, we get the product, that is alcohol. So what you need to do here, you have to remove COH and add CH2OH. In the place of COOH, keep CH2OH. It is the hint which I want to tell here, that is remove COOH and add CH2OH. In the place of COOH, keep CH2OH. That will give the product very easily. Similarly, when we take the example, that is if the R is a CH3 group, CH3COH, that is acetic acid. So when we are doing the reduction, so what we need to do here, remove the COH and add CH2OH. So that gives rise to the product, that is alcohol. Thus, carboxylic acids are reduced to the primary alcohol easily by the lithium aluminium hydride, which is a strong reducing agent. However, the lithium aluminium hydride is an expensive reagent. Therefore, used for preparing special chemicals only. That means commercially, acids are reduced to alcohol by converting them into ester. So as you can see here, the acid is first converted into ester and then we can do the reduction to give rise to alcohol. So why it is done? In order to we prepare commercially. That means on the large scale, if we want to prepare the alcohol from acid, first the acid is converted into ester and then the ester undergoes reduction to give rise to alcohols. In this reaction, we can see that first the acidic group, that is COH group, it is converted into ester with the reaction of alcohol. So acid plus alcohol give rise to ester. That is reaction called as esterification, which we are going to discuss in the chemical properties of alcohol. So first the acidic group is converted into ester, and the ester, it undergoes reduction by reaction with the hydrogen in the presence of catalyst to give rise to mixture of alcohols. You can find out here there are two alcohols are formed. That means mixture of alcohols are formed here. When you compare the structure of ester, in the ester group, two alkyl groups are there, that is R and R dash. So this RCO, these give rise to one alcohol, that is RCH2OH, and the R dash O give rise to an alcohol, that is R dash OH. So you need to break the bond from here. That is RCO give rise to this alcohol, and R dash O give rise to this alcohol. So there is a formation of two alcohols, that is RCH2OH and R dash OH. R dash OH. So two alcohols are formed. So we can see that we get a mixture of alcohols by the reduction of esters. Next, preparation from Grignard reagent. In the previous chapter, we discussed about Grignard reagent. So how we can prepare the alcohols from Grignard reagent? Grignard reagent, generally we are representing RMgX. Grignard reagent are represented as RMgX, where R is the alkyl group, Mg is the magnesium, X is the halide. Now first of all, we'll make a general equation here. So with the help of general equation, you can easily frame the product with the examples. So for the carbonyl compounds having C double bond O group, that is taken here. So let us discuss how this reaction takes place. As we know that in the carbonyl, the carbon is actually having a partial positive charge and the O having partial negative charge. So because of this reason, the R negative, this is the negative part, it will get combined on this carbon, and the other part, that is MgX, get attached with the oxygen. Nothing here, positive comes with the negative, negative comes with the positive. So we get an intermediate here, that is called as adduct. So the first step in this reaction is a nucleophilic addition of Grignard reagent to the carbonyl group to form an adduct. Now next, when we do the hydrolysis of adduct, yields the alcohol. So how we make this product? Let us discuss that. So once this product is formed, hydrolysis, how we can do the hydrolysis easily? You need to break the bond from here and add one H this side and add OH on this side. So you need to mark this all, what I am doing, the breaking and all, with the help of pencil in your notebook. So next time when you are doing that, you can be easily get the product when you do in this manner. So break this bond and add one H on this side, add one OH on this side. So you will get the product. Check the product here. That is CrOH. You can see one O is added with the H. So we have got a OH here. And the second product, this will give the other product, that is MgOHX. This is the side product which is formed here. So we get here the two products are formed, that is alcohol is formed and MgOHX is formed. So this is the general equation which you need to learn first. And when we get a particular equation, you have to frame in the same manner. For example, this equation, that is methanol. Methanol is a formaldehyde. So here 2H is there. So you have to keep the 2H on all the side, you can see. So when you compare the previous equation, this equation when you compare, here we have not written anything here. And we are taken generally R here. So when a particular alkyl group is taken and when particular here is added, then we'll get a particular aldehyde and ketone. So let us do this equation. Everything is same, only you have to keep a H on these two sides. So you can say wherever you have this, H is there. So whatever the group there, it's not matter, you write in the same manner. You have to make changes only on this side. So you get a here this part, that is a alkyl group get attached on this carbon, and MgX get attached on this oxygen. So we get an adduct. When we do the hydrolysis, breakage of this bond, add H this side, add OH this side. So we get this product. So when you compare this structure here, when you find it here, you are getting a primary alcohol here. The product is primary alcohol. That means when we do the reaction with Grignard reagent of methanol, we get a primary alcohol. Let us take another example, ethanol. In the ethanol, you can see we have only made the changes here. CH3H, here we are making the changes, and the alkyl group we are taking methyl group. So we are getting a alcohol, that is secondary alcohol. Secondary alcohol we are getting. Next, take a ketone, that is propanol. Ketone, here two CH3 are there. So you need to keep the CH3 on the both side. I told you everything is same, only you have to keep the changes on the alkyl group which is present and the R in the Grignard reagent. It is CH3, so you are adding CH3 here. If it is C2H5, you have to keep C2H5 there. So depending upon the R, you have to make the product. So that is the reaction with propanol, and it gives rise to tertiary alcohol. So when you compare the examples like methanol, in this you can find out the number of carbon atom is increased, because here there is only single carbon atom, that is in a single aldehyde, single carbon aldehyde, and here we can see that there are two number of carbon. So that means the carbon number is increased. So by this reaction, carbon number get increased, and how much it is increased, that depends upon this group, that is the alkyl group in the Grignard reagent decide how much carbon is get increased. So here CH3MgX, here CH3, that is one carbon alkyl group is taken, therefore there is increase in the one carbon atom in the product. When you compare the next structure, that is the case of this structure. In this structure you can find out initially there was a single methyl group and C. So we can say total 2 carbon atom are there, but in the product side when you find it out, there are 1, 2, 3 carbon atoms are present. So that means there is an increase in the carbon atom by 1. Why? Because we have taken CH3 in the Grignard reagent. So CH3 have 1 carbon atom, so 1 carbon atom is increased. In this also you can find out 1 carbon atom is increased. So what shows that in this all reaction, that is the reaction of carbonyl compounds with the Grignard reagent, there is a increase in the carbon numbers. So alcohol can be prepared from aldehyde and ketone by reacting with Grignard reagent. In this all reaction, the carbon number get increased. And how much it is increased? It is depending upon the alkyl group of the Grignard reagent. So the reduction which we have discussed, that is the reduction of carbonyl compound. In this all case, we have find it out that there is no change in the number of carbon atom. Carbon atom is remains same in the case of aldehyde and ketones and the product alcohol. So whenever we are preparing an alcohol with the same carbon number, we have to use the method reduction of aldehyde and ketone. But if we want to increase the number of carbon atom in the product side, that is alcoholic side, at the time we have to use the reaction of carbonyl compounds with Grignard reagent. So it is very important point when we are doing the conversions. So whenever we want to increase the carbon atom numbers, we will be using the Grignard reagents. Next reaction, that is preparation of alcohol from alkenes. In this, first we will be going to discuss by acid catalyzed hydration of alkenes. Alkenes, C double bond C, here it represents an alkene. It is a general equation plus water. That means alkenes react with water in the presence of acid, which is used as a catalyst here to form alcohol. So this is a general equation which is given here. In this equation, you have to follow this way to add. H2O means H plus and OH negative. So we can say that H get added on this carbon atom and OH get added on this carbon atom. So here the more focusing part is this part. That is C double bond O is our focusing area here. And water, you can split the water as H plus and OH minus. Keep H plus on the one of the carbon atom and keep OH on the other carbon atom. So in this way you get this product, that is an alcohol. In the case of symmetrical alkene, it is not a problem where you need to add, but in the case of unsymmetrical alkene, you have to follow a rule, that is Markovnikov rule you have to follow. So as we have done the addition of HBr, in the case of alkene, we have used the rule, that is a Markovnikov rule. So in the case of addition of water also, you have to follow the same rule, Markovnikov rule. So let us try this equation number 2, that is a reaction of propene with water in the presence of acid H plus. So in this you can find out here, this is called as unsymmetrical alkene. Why? This is our focusing area. When you look at this carbon atom, here there is a single hydrogen and here there is 2 hydrogen. So which have a minimum number of hydrogen? That is this one. So the negative part of that OH negative get added on this carbon and H plus get added on this carbon. So we get this product. So in the case of unsymmetrical alkene, we have to follow Markovnikov rule. According to this rule, the negative part get attached to that carbon atom which have less number of hydrogen. So in this negative part is OH negative. So that you need to add on which carbon atom? The double bonded carbon atom which have less number of hydrogen. Next, alkenes by hydroboration oxidation reaction. So let us discuss this equation. In this reaction, there is a reaction between alkene with diborane. Remember, last year we discussed about diborane, that is B2H6. So, the reaction of alkene with diborane, it gives rise to trialkyl borane as an addition product. That is, this gives rise to this product, that is trialkyl boranes, and which on oxidation with hydrogen peroxide will give rise to alcohol as a product. So how this reaction takes place? First of all, let us discuss this equation. First, actually, this reaction with the diborane, it gives rise to this product. That means here the BH2 get added on this carbon and H get added on this carbon. So we get this product. Again, when we treated with one more alkene, the same alkene we have taken, so we get this product. That means diboranes is formed, and again reaction with alkene give rise to triborane, and which on oxidation with the H2O2 give rise to this alcohol. So how easily we make the product by this reaction? So only you need to remember this one, that is the reaction in which you have to follow anti-Markovnikov rule. So how we have done the hydration of alkene, similarly we have to do hydration of alkene, but the use of anti-Markovnikov rule. When you use the anti-Markovnikov rule and when you add OH negative, H plus and OH negative, OH negative, the negative part should be added on that carbon atom which have large number of hydrogen of that carbon which is doubly bonded, and H get added here. So we get this product. So directly we can make this product. How? By using the anti-Markovnikov rule, addition of H on this carbon and addition of OH on this carbon. So the whole reaction which we have discussed here, so instead of making this steps, directly we can come to this product by this method, that is by this method, use of anti-Markovnikov rule. So whenever in the complete the reaction, usually it is given in this way, that is after doing the first step and second step, you have to find the product. So that product is this product. So in this video, we discussed about the preparation of alcohol from haloalkane, that is a nucleophilic substitution reaction. Then we have discussed the reduction of carbonyl compounds which give rise to alcohol, and in that the reduction of aldehyde, reduction of ketone, reduction of acid, and reduction of ester we have discussed. And we also discussed about the preparation of alcohol from Grignard reagent. In this case, that is in the reduction of carbonyl compound, the alcohols formed have same number of carbon atom as the carbonyl compounds are there. But in the case of this reaction, we can say that the carbon number is increased. And we also discussed about the preparation of alcohol from alkene, that is acid catalyzed hydration of alkyl, that is addition of water in the presence of acid, that give rise to alcohol. And we also discussed about hydroboration reaction. So when you compare these two reactions, in this reaction you are using Markovnikov rule, and in this reaction you are using anti-Markovnikov rule. So that is all about the summary of this video. So in the next video, we'll be discussing the mechanism of which reaction? The mechanism of this reaction which we need to discuss, that is the acid catalyzed hydration of alkene. Its mechanism we need to discuss. That will be discussed in the next video. So this is all about this video. We are winding up this video. Thank you everyone.